Okay, so here's a lemma. So one, it says that the push forward of a fibration is a fibration, or sorry, a pullback of a fibration is a fibration, and the other thing is that a push forward of a fibration or push out of a cofibration is a cofibration. Okay, so let's do the proofs. The proofs are really easy, but they're a good exercise in basic category theory, right? So for the proof for the first one, so what we do is we suppose we have a fibration. So suppose, so this thing is a fibration. Okay, and so what we'll do is we'll pull it back. Okay, so here is what we have. So we have E, X, like so, and then we have Z. And then so then this is F, and then this is the pullback here. The pullback by, say, G. Okay, so this is E, Z, and it goes like this. So this is this thing here, this map here is the pullback of F by G. Okay, and so what we need to do is we need to check that this is a fibration. So we need to check that it has the homotopy lifting property. Okay, in particular, so if we have some test thing here, right, and then we have a homotopy here, and we have some seed homotopy, so some beginning of some lift of the homotopy here, right? We want to get a map from here to here. Just for clarity purposes, let me kind of like write down the other notations. So EZ, this is E cross Z, E cross Z over X, right? And sometimes this is called G star of E. Okay, so this is the pullback. The pullback, I mean, it really comes with the map, but anyway, so it's really this thing here. This is the pullback. So I guess we could call this G subscript Z if we wanted to. Anyway, back to here. So we wanted to show that this pullback is a fibration, right? But we know that this one here, this is a fibration, right? And so we have a map here and we have a map here. And so by F being a fibration, so this map exists because F is a fibration. So I don't know, what should we call that? So we'll call that H tilde. So H tilde exists. So H tilde exists since F is a fibration. Right? But then we got to use the universal property, right? So we have a map from here, it goes to E and it goes to Z and it's over X. And so by the universal property, we get this map. So F tilde exists by the universal property of fiber products. Okay, so that's all we do for this one. Okay, similarly, we'll do the same thing for the pushout diagram. Okay, so what is the pushout diagram? So we're given. So suppose that I A to X. So this is an inclusion. Is a cofibration. Okay. Then we need to conclude that the pushout has a cofibration, right? So here's what we'll do. Okay, so suppose this is a cofibration, then and then we're going to take a map that we're going to push out by. I guess we could call it G2. So here's what we'll do. So we'll have A to X. So we have A. Okay, so we have A to X. And then we have, then we have a map to B. So we'll call this is like our map G. And then we have the pushout. A over B. Okay, so this thing here, this is our map I, and so this is the push out. And then we want the homotopy extension property. Okay, so so this is our push out, and then the next part will be given, and then we need to show that there's a lift. Okay, so this part here, so we're given a test map like so, and so this is evaluation at 0. This is what we've been calling maps, from here to W. Okay, and then so we want to show that there's a map here making the diagram commute. Okay, we do know, however, there exists a map here, so we could call this F or H tilde. So H tilde exists by the homotopy extension property of the map I. Okay, and then and then what we do is we get this map here, this one here, F tilde. Let's see, not this one, but we get this map here, F tilde, exists by the universal property of the push out. Of push out. Okay, and that's the two proofs. But let's just examine this. Okay, so so what do we have? We have a map from B to here, and we have a map from X to here. This one existed by the homotopy extension property. Okay, and okay, so we have a map from here to here and here to here, and it commutes with these two inclusions, right? Hence, we'll get a map from here to here by the universal, since this is the initial object that satisfies in that co-cone. Okay, so that's the universal property of the push out. All right, so yeah, and so that's the two proofs of these facts.